Hi everyone, so we have studied the clipper circuit in the previous videos. Now we are going to study about the clamper circuit. So what was clipper circuit doing? It was clipping of the undesired part of the input signal without changing the rest of the part of the signal. Clipping of the undesired part. Now what will clamper circuit do? It will clamp up or clamp down. That means it will shift up or shift down the input signal. It can shift up as well, it can shift down as well, but it will not change the appearance of the signal. Now this is a square wave, so it will be a square wave only, but it can be shifted upward or downward. So you can read the definition: circuit that shifts the waveform of the input signal to a desired reference DC level. Desired reference DC level, what do I mean by that? That I will explain, without changing the actual appearance of the input signal. Okay, so yeah, tell me the DC value of this one. Simple network analysis, if you have studied, what is the DC value of this waveform? That is 0 volt, right? DC value is 0 only. Now by using the clamper circuit, what I can do, I can either shift it upward or shift it downward. So let's assume I shift it upward by Vm by 2. I am shifting it upward by Vm by 2. Shifting it upward by Vm by 2. So what will happen? This Vm is shifted upward by Vm by 2. So the positive magnitude will become 3 Vm by 2, right? And negative would become minus Vm by 2, because it is shifted upward. Minus Vm is shifted upward by Vm by 2. So minus Vm plus Vm by 2 would be minus Vm by 2. Like this, it is shifted upward. Right? This is V naught. Here I can write shifted upward by Vm by 2. So this magnitude would become 3 Vm by 2, and this magnitude would be minus Vm by 2, right? And this is time t, this is time t by 2. So tell me, what is the average value now? What is the average value? Average value would be Vm by 2 only. You can calculate it, or simply if we are shifting it upward by Vm by 2, so average value would be Vm by 2 only, right? So this would be our average value. This is our average value, which is Vm by 2, right? So I had this input signal. What I did, I just added Vm by 2 in this one. That's it. This is what I did. I just added Vm by 2 in my input signal. That's it. Now what I will do, I will subtract the Vm by 2 in my input signal. So this output also I can get, or this output also I can get. So now I will subtract the Vm by 2. So what is the output I will be having? If it is subtracted, that means Vm minus Vm by 2. So it would be minus Vm by 2, and then the lower one would be minus 3 Vm by 2. This would be Vm by 2, and this would be minus 3 Vm by 2. And in the same way, it will get repeated. This value will be minus 3 Vm by 2. And what will be its DC value? DC value will be minus Vm by 2. DC value will be minus Vm by 2, right? So this is what a clamper circuit do. Now we are going to design a clamper circuit. So first see the classification. Just like the clipper circuit, there will be classification of clamper circuit as well. So positive clamper, negative clamper, positive bias clamper circuit, negative bias clamper circuit. So as I told you in the clipper circuit, the classification is not important at all, because no one is going to ask you about the classification. So forget about the classification, don't focus much on that. Positive clamper, what do I mean by positive clamper? That means it will shift the waveform upward. Shifts the waveform upward. Shifts the waveform upward. What will negative clamper do? Shifts the waveform. This pan is not working. Downward. Clamper circuit with some bias, like it will be positive or negative, but there will be some bias as well. Okay. Now let's try thinking of a circuit. What do you need in the output? Here I told you what do you need in the output. The input signal as it is plus some DC value. What do you need? You need your output to be somewhat like this. Input plus some DC value. This is what you need. So basically in the output you need something more. So what do you think, which element you need here now? An element which can store some DC value. If you need something in output, something added, so you would need a storing element in your circuit. Now what are the storing elements that you know? Inductor and capacitor. But which element stores the voltage? Capacitor. Inductor stores the current and capacitor stores the voltage. That means certainly I would be needing a capacitor. That's for sure. I would be needing a capacitor to store a DC value. I will have an input here and I need a capacitor to store a DC value. What else I would need? I would need a switch, right? Like if I turn it on, what will happen? The input part will be coming to the input part will be coming across the capacitor only. If I turn the switch on, what will happen? The capacitor will be exposed to the input only. ये सीधा input सीधा capacitor के parallel में आ जाएगा. So now this capacitor will be charged to this input only, right? And then if I turn off the switch, now if I turn off the switch, what will happen? If I turn off the switch, what will happen? There will be no path for the capacitor to discharge, right? If I turn off the switch, there will be no path for the capacitor to discharge. That means it will be storing that particular value. So my output will be V in minus DC, or somehow if DC value is negative, so it would be V in plus DC. Are you getting this point? So we need switch and a capacitor. So basically for switch we need a diode. This can happen with a diode, right? So with the help of a diode and a capacitor we can make a clamper circuit. Even if you did not understand the mechanism, I will certainly explain it. No worry, don't worry about it. But I just wanted you to think about the circuit, like what you would be needing. Why we need a capacitor? Because it is a storing element, so we need something amplified in our output, something shifted upwards or shifted downward. So for that we need a DC value, and who can store a DC value? That is the capacitor. So that's why we need a capacitor. Then along with that we need a switch. And what is the simplest switch? That is diode. So a diode and a capacitor we can use. So before moving on to the concept, let's do a revision question, a simple revision question. So here what I am doing, I am turning on the switch at t equals to 0. First the switch is closed at t equals to 0, then switch is turned off. That means it is opened again at t equals to 5 seconds. So you need to tell me the value of V0 at t equals to 0, 1 second, 5 second, 10 second and 20 second. This is your task. Okay. So you need to tell me these values. So what I am doing, I am turning on my switch at t equals to 0. Better I should write t equals to 0 plus here. Okay. T equals to 0 plus. You need to tell me the value of V0 at t equals to 0 plus 1 second, 5 second, 10 second and 20 second. RC value also you should see, that is 50 kiloseconds. RC value is 50 kilosecond. 50 into 10 to the power 3 second. That is the RC value. So what I am doing, I am turning on my switch. This is V in and this is V out. So just as I turned on, what will happen? Tell me. The complete voltage is exposed to the capacitor. So the complete voltage, whatever the input voltage that we are having, that will be completely going towards the capacitor. Let's assume this input voltage is 5 volt. This input voltage is 5 volt. This is what we are assuming. So the complete input voltage will be going towards the capacitor. Till what time? Till the time the switch is on. So your V0 value at t equals to 0 plus will be what? 5 volt only, because this input we are assuming to be 5 volt. What will be value at t equals to 1 second? T equals to 1 second. It will be 5 volt only. It will be 5 volt irrespective of the RC value. Okay, you guys must be thinking that RC value is very large. That's why capacitor is not discharging. That's why it is 5 volt. Otherwise, it would have discharged. No, no, no. It would not have discharged. It will never discharge because the input voltage is directly exposed to the capacitor. So the capacitor voltage will always be equals to input voltage only, irrespective of the RC value. Even if the RC value was very low, still V output will always be 5 volt only until the input is there. If the connection from input is broken, then something can happen, then it can discharge. But until input is there, no matter whatever the value of RC is, V0 will always be 5 volt because it is directly there. And if you have studied network analysis from me, so I have told you one concept, that infinite current concept. So if you see this circuit, C, R, right, and input voltage is there. So if capacitor is shorted, that means there is infinite current flowing through the capacitor. And if the current is flowing infinite in the capacitor, that means the capacitor can change its voltage instantaneously. So from 0 volt to directly it is going to 5 volt because it is changing its voltage instantaneously. Why so? Because there is infinite current flowing through it. Or you can understand it by this point, that complete input voltage is exposed to the capacitor. So the capacitor is charged to input voltage only, right? So till 1 second this is the case. Now at this should I write 5 minus second, then I would ask you at 5 plus second as well. You can tell me at 5 plus second what will happen. So now I am writing at 5 minus second because till 5 minus second the switch is on only. So if it is on only, so it will be 5 volt only. Now after that what will happen? The switch is turned off. So this is for 0 to 5 second. 0 to 5 second. Now what will happen after that? So for t greater than 5 second. Now input is gone, but the capacitor is charged to 5 volt. This capacitor C, it is charged to 5 volt, but input is gone now. Why so? Because the switch is open. The switch is open, so there is no connection of input to the circuit. So input is other side, circuit is other side. And this is R. So now what should happen? That ideally this capacitor should discharge and V0 value should follow something like this. V0 should be 5 into e to the power minus t by RC. So the capacitor should discharge with the time constant of RC. But will that happen? What is the value of RC? RC is 50 kilosecond. That means it is 50 into 10 to the power 3 second, which is very large, right? So, but we are talking about 5 second, 10 second, 20 second. That means gap of 5 second, 10 second, 15 second. This much of gap only. So in 15 second, how much voltage will be discharged? Nearly zero only, right? What do I mean to say? Like our capacitor will discharge something like this, 5 into e to the power minus t by RC. So I can write 5 into e to the power minus t by RC is 50 kilo. RC is 50 kilo. Now I am asking what will be the output voltage at 10 second. At 10 second, that means from 5 to 10 second, because the switch was closed at 5 second only. So you had the window of 5 second only. So in 5 second, how much it would discharge? 5 into e to the power 5 by 50k. So calculate this value. It will be nearly 5 only. You can calculate it in your calculator. It will be nearly 5 volt only, right? So it will be nearly 5 volt only. So the capacitor will not discharge. Since RC value is very large, since time constant is very large, that means the capacitor will not discharge, and for a very long time it will be at 5 volt only. Are you getting this point? Since RC is very large, capacitor will not discharge very quickly and remain at 5 volt for a very long time, right? So V naught value at t equals to 5 plus second, or V naught value at 10 second, or V naught value at 15 second, 15 second, or V naught value at t equals to 20 second. It will always be 5 volt only. So if you have set the value of R such that, or C such that, or the product of RC such that the RC value is very large, then the capacitor will not discharge so much quickly and the output voltage will be constant. Why I have picked this question? Because this concept will be used in the further analysis. That's why I picked this question. And now we can move on to the next part. The pen is not working fine today. Let me pause the video. Okay, so let's move on to the next slide. Now we will study about positive clamper circuit. Positive clamper circuit. Why is it called positive clamper circuit? Because it shifts the input waveform upward. So now we will see how it shifts the input waveform upward. Here RC value is set such that RC value is very large. In the exam, what they can do, sometimes what they do, they don't even give the value of R. What do I mean to say? They just ignore this R. They just keep it open circuited. So if they are keeping it open circuited, what does that mean? That R is infinity. If R is infinity, that means RC value is already very large, right? And if they give the value of R, most probably they will give the value of R to be very high. And if they don't give the value of R to be very high, how to solve those problems? Those also I will deal. Okay. So if the value of R is not very high, so how to solve those problems? That also we will see. No worry about that. So for now, for the analysis, we are assuming RC value to be very large. So now tell me what will happen. Initially, we will plot two waveforms, V0 waveform and VC waveform. So initially, at t equals to 0, VC0 minus is, VC0 plus is 0 volt only, because capacitor is not charged, right? Now this same, if the capacitor is not charged, that means it will be shorted only. Now this same input will be going towards the diode, right? The same input will be going towards the diode initially at t equals to 0. Now the input is increasing, that means input is positive. The diode is ideal. Now input is increasing, that means input is positive. What will happen? There will be some positive voltage across this diode. Let's assume that is 0.1 volt. What will happen? This is positive and this is 0. So the diode will be off. Are you getting this point? That means whenever input is positive, whenever V in is positive, diode will be off only. Are you able to grasp this point or not? Initially, there is no charge on the capacitor. So if input goes across the diode, the same input is going across the diode. Now, if input is positive, that means diode is having some positive voltage, but N side is positive and P side is 0. That means diode will be off. Are you getting this point? So, for V in greater than 0 volt, what is happening? Diode is off. So, if diode is off, what will be our circuit? This will be our circuit. This is VC and this is V in. Now what people can think, the people can think that what if the capacitor starts charging? But I told you one thing, the RC value is very large, so the capacitor will not even charge, right? Now people can say that in this t by 2 time, from 0 to t by 2, for V in greater than 0, that means this I am talking about for 0 to t by 2. So for 0 to t by 2, for 0 to t by 2 time, people can think that the capacitor can start charging, but the value of RC is such that it is very large, so the capacitor will not even get time to charge. What will be the capacitor charging equation? That would be, it will be charged to V in voltage. So V in into 1 minus e to the power minus t by RC. Now RC value is very large, or they would say that RC value is very larger than time period, or they can say that time period is very less than RC. So RC value is very large. So what we will see here 1 minus e to the power in t by 2 time. I am taking the complete window t by 2 RC. Now since this value is very low and this value is very large, so the complete value will go to 0 only, right? So this complete value will go to 0 only. So 1 minus e to the power minus 0. So what it will be? It will be it will be 0 only. 1 minus e to the power 0 is 1. So it will be 0 volt only. So in the time period t by 2, the capacitor will not even charge. If the RC value is very large, that means it can neither charge nor discharge. Are you getting this point? It needs a very large window to charge or discharge. Okay. So it's neither. So it's neither charging nor discharging. That means my V naught will be equals to V in only and Vc will be equals to 0 volt. Did you get this point? The complete V in is coming across the output only because capacitor is not even charged. So for 0 to t by 2, V naught is equals to V in only and Vc is 0 volt. So for this much of time, we can plot the output waveform. Vc is 0 volt till t by 2. And V naught is equals to V in only. Now what will happen? The negative cycle will come. So we are analyzing for, actually I should add a page after this. Okay, so now let's see for time t equals to, t by 2 to 3t by 4. Okay, t by 2 to 3t by 4, t by 2 to 3t by 4, or you can write that t is greater than t by 2 and less than 3t by 4. So for this time, now we will see. So what will happen? The capacitor is discharged only. The capacitor is at 0 volt only. There is no charge on the capacitor. So what will happen? Again, the complete input voltage will be going across the diode. Again, this complete input voltage will be going across the diode. No problem with that. So now this complete voltage is going across the diode. Just as you see at t by 2 plus, there will be some negative voltage. At t by 2 plus, there will be some negative voltage. What does that mean? That let's assume that negative voltage is 0.1 volt, minus 0.1 volt. So what will happen? It will come like this. Because input is negative, that means input is negative, it is flowing like this. The current is flowing like this in the opposite direction because input is negative. If it was positive, it was flowing like this. Now if it is negative, it is flowing like this. That means the diode turns on. Are you getting this point? So at t by 2 plus, the diode turns on. Forget about this timing. Why I took 3t by 4, why did not I took time t, that we will understand. So forget about this timing, forget about this 3t by 4. Let's just check at t by 2 plus only. So at t by 2 plus, what is happening? The diode turns on. And if the diode turns on, what will happen in the circuit? This is the capacitor C. This diode turns on. Diode turns on. We are having our input voltage here. And this is what we are calling Vc. And this is our output. Here in the parallel, we are having a resistor as well. But I did not make that resistor. Why so? Because there is no relevance of that resistor. Right? A resistance R is there. In parallel, there is short circuit. What is the equivalent of that? R parallel with 0 ohm resistance. So R into 0 upon R plus 0. That will be 0 only. So equivalent of this is simply a shorted line. So that's why I did not make the resistance R. This resistance R is not open circuited. It is shorted. So there is no relevance of resistance R. So that's why I did not make it. So tell me, when the diode turns on, what is happening? The capacitor is getting charged, right? Why capacitor is getting charged? Because the complete input is exposed to the capacitor. The complete input is exposed to the capacitor. That's why now the capacitor is getting charged to the input voltage. So your Vc is equals to your input voltage. Now what is our input voltage? This is our input voltage, right? From T by 2, negative voltage is there, and let's assume this is our 3T by 4, but we are not putting it. This is our input voltage. So negative voltage is there, that means the current will be flowing like this. So the capacitor will be charged in this direction, in the negative direction. Are you getting this point? Did you understand this point? If Vin was positive and if the capacitor was getting charged, let's assume this is our circuit and this is my Vin. I am calling this as my Vin. So how will the capacitor get charged? Vc voltage in this direction, because the current voltage is positive, so the current will be flowing like this. Now if the voltage is negative, this is my Vin and this is my voltage now. So what will happen? The negative, that means current will be flowing in this direction, so capacitor will be getting charged in the opposite direction. But we are, for the sign convention, we are taking Vc in this direction, from left to right, in this direction. Vc is like this. So Vc is getting charged in the opposite direction, or you can see, or you can understand that the Vc is simply the input voltage only. Vc is simply equals to the input voltage only. And what is our V0? V0 is 0 volt only. But till what time it will remain 0? Let's check out one thing in the capacitor. Let's assume my capacitor is charged to 5 volt. Okay, there is something here, I don't know. And here I have applied 5 volt only. So what will be the voltage here? 0 volt. Let's assume this is our diode. This is our diode. Okay. Assuming that I have applied, my capacitor is charged to 5 volt, I have applied 4 volt here. So what will be the voltage here? It will be minus 1 volt, right? Minus 1 volt. That means diode is on. Now if I increase my voltage, I increase my voltage to 4.9. If I increase the voltage for 4.9, what is the voltage here? That would be 4.9 minus 5. That means it would be minus 0.1 volt only. Just taking a condition, okay? Don't think that the capacitor will be charged to this voltage or that voltage. I am telling you a concept here. Now what if I increase my voltage to 5.01? What will happen? If I increased my voltage to 5.01, what will be the voltage here? This is fixed. Somehow it is fixed. Somehow the capacitor voltage is fixed. So this is at 5 only and this is at 5.01. What will happen now? Where will this voltage go? 5.01 minus 5, 0.1 volt. And now if it is 0.1 volt, what will happen? This diode will be turned off. Diode is off. Right? The diode is off. So you just always need to take care of the next voltage. Now for T by 2 to 3T by 4, what was happening? Your Vc was getting charged in the negative direction. So your Vc was getting charged like this. So till 3T by 4, this is 3T by 4. So till 3T by 4, it has charged to some negative voltage that we can call minus Vm or minus 5 we can take. And till that time, your V0 was 0 only. So for 0 to 3T by 4, your V0 was 0 only. Now your capacitor is charged to minus Vm. Minus Vm, that means what will be the direction? Direction will be this. You can write like this, Vm like this, right? At 3T by 4. So what I can write, that my Vc value at 3T by 4 is minus Vm, because Vc value we are taking in this direction and the capacitor is getting charged in the opposite direction. So Vc value at 3T by 4 is minus Vm. What is my V0 value at 3T by 4? That is 0 volt. Let's check what is happening at 3T by 4 plus. This is the most important, most interesting part. What is happening at 3T by 4 plus at t equals to 3T by 4 plus. Let's make our circuit again. This was our diode only, no? Yeah. This was our diode only. This is the resistance R. This is the most complex part of the clamper circuit. If you understand this part, you will never face any problem in the clamper circuit. That's my guarantee. And this is the input voltage. Now it is charged to Vm voltage in this direction. Let Vm is 5 volt. Let Vm is 5 volt. So it is charged to 5 volt in the opposite direction, in this direction, right? Now what is happening? V in value at t equals to 3t by 4 plus. What is that? It is greater than minus 5, right? Let's make the input voltage here. This is 3t by 4 and this is time t. This is your V. So add 3t by 4 plus this will be the value. If this was minus 5, this could be minus 4.9. Let's assume this is minus 4.9. Assuming it to be minus 4.9. So if here it is minus 4.9, what will happen? Minus 4.9 plus 5. That means here what you will get? Plus 0.1. And if you are getting plus 0.1 here, that means now your diode will be turned off. Are you getting this point or not? Your diode is turned off now, right? Did you understand this point? My capacitor is charged to 5 volt. My capacitor is charged to 5 volt, but it cannot change its voltage immediately. It has to remain there at 5 volt only. At 3t by 4 plus, what is happening? Suddenly, the input is getting changed to minus 4.9. So minus 4.9 plus 5, that means across the diode, I am having 0.1 voltage. That will turn off my diode. Are you getting this point? So now my VC voltage will be there at minus 5 volt only. This is my VC. This is my VC. Now my capacitor will be charged to 5 volt only in the opposite direction, although, but now my capacitor will be charged to 5 volt only. If you want to turn on this diode, how much input voltage you should apply? Tell me. If you want to turn on this diode, how much input voltage you need to apply? This is my input. My capacitor is at 5 volt, right? Because diode is off. Now my capacitor cannot charge, cannot discharge. So the capacitor will be at 5 volt only. Now I am thinking when can my diode can turn on? What will be the point where my diode can turn on? I am thinking about that point. So what is my diode voltage? That would be V in plus 5 volt, right? I need to turn on my diode. That means this voltage, VD voltage, this is my VD voltage. That is V in plus 5 volt. This should be less than 0. That means my V in should be less than minus 5. So to turn on the diode, I need my input voltage less than minus 5. Is that possible? No, because my peak to peak voltage is plus 5 and minus 5. And less than that, I cannot go. That means my diode can never turn on, never. Now my diode can never turn on. That means my capacitor can never further charge, right? Or further discharge. So my capacitor will be at constant 5 volt only. Did you understand this whole point or not? I made you understand the complete concept of clumper circuit here. What is happening? Capacitor was charged to 5 volt. Now suddenly my input got changed to minus 4.9. So what will happen? The diode will be having some positive voltage. That means diode is turned off. Now what I am thinking that okay, I can analyze the further circuit, but I need to think when will my diode will turn on. If my diode is not turning on, that means my capacitor can never charge, never discharge. It will be at 5 volt only, right? So after that, it can never charge, never discharge. So it will be at 5 volt only. This is what I need to think, right? So what did I do after that? I thought that I need to turn on my diode. So what is my diode voltage? Diode voltage is V in plus 5 volt. Diode voltage is V in plus 5 volt. So I need to make that less than 0. How do I make that less than 0? That means my input voltage should go lesser than minus 5 volt, which is not possible. That means my diode will always be off only. And if my diode is off, that means capacitor can never charge, never discharge. Why so? Because RC value is very large. If RC value is very large, it can never charge, never discharge. So the capacitor voltage is constant at 5 volt only. So what will be my output voltage now? Output voltage will be V in plus 5 volt. That's it. And that was my target, to shift the waveform upward. So now always my output voltage will be V in plus 5 volt. That's it. That was my target and I achieved it. Are you getting this point? Now we will write it all. So what I can say, V in at 3t by 4 plus will be some minus 4.9 volt. This is, we are assuming, let minus 4.9 volt. So what will happen? Diode turns off. Diode turns off. And if diode turns off, what will be the circuit? This will be the circuit. And what is one thing? Since RC value is very large, RC is very large, cap can neither discharge, capacitor can neither charge nor discharge, right? And to turn on the diode, what should happen? V in plus 5 volt, V in plus 5 volt should go less than 0. That means my V in should be less than minus 5, and it is not possible. And if it is not possible, that means my VC will always be at minus 5. That means VC voltage will always be minus 5 volt, always. And what will be my output voltage? V naught will be V in plus 5 volt. Because VC 5 volt is there, so V in plus 5 volt is my V naught. So this will be my output voltage forever, right? So at steady state, this is my output voltage, and this is what I wanted to achieve. So till this point, this is at minus 5, and always it will remain at minus 5 only now. This is my VC waveform, and what is happening with my input? Now it is shifted upward by 5 volt. So here minus 5, it is 0. At minus 4.9, it will be minus 4.9 plus 5, so 0.1. Right, like this it will rise. At 0, it will be 5 volt. When V in voltage is 0, what will be my output voltage? When V in voltage is 0, output voltage will be 5. So it is rising like this. Output voltage will be 5. When input voltage is 5 volt, what will be my output voltage? When input voltage is 5 volt, output voltage will be 10. When input is 0 volt, again it will be 5. And when input is minus 5, it will be 0. Right? Are you getting this point? So let's make those points. This is 5 volt, this is 10 volt, or we should say 2 Vm. When input is Vm, it will be 2 Vm. And when it is minus Vm, it is 0. Right? And when this is 0, it will be Vm again. So like this, the waveform will get repeated. It will keep on repeating like this. Well and good. Right? So it will get repeated. So my output is V in plus Vm. So this was our positive clamper circuit. This is 2 Vm. Well and good. This time is T plus T by 4. That would be 5T by 4. Right? It is correct only, right? T plus T by 4. 5T by 4. Yeah. So have you understood the complete analysis? Just let's quickly go through it. What was happening? Initially, there was a voltage, input voltage, which was positive. If input voltage was positive, that means diode was not even turned on. That means the output will simply be equals to input voltage only, and there will be no charge on the capacitor. So for 0 to t by 2, for 0 to t by 2, there V0 was 0 volt only, and the capacitor V0 was equals to input voltage only. V0 was equals to input voltage only, and Vc was 0. Now what is happening? The input voltage is negative. That means the diode will turn on. If the diode turns on, the output voltage is 0, but the capacitor is following the input voltage. That means the capacitor is charged in the negative direction. Now it is charged till 5 volt in the negative direction. That means it is charged till minus 5 volt. Now if the input rises up, that means input is 4.9 volt minus 4.9 volt. That means the minus 4.9 plus 5, that means capacitor with the diode will be off. If the diode is off, now to turn on the diode, we need the input voltage to be lesser than minus 5 volt, which is not possible. That means diode will always be turned off. That means diode will always be open circuited. So my output voltage will be fixed, and that will be Vin plus 5 volt, and the capacitor will always be at minus 5 volt only. So this will be my final waveform of Vc voltage, and this will be my final waveform of output voltage. So are you understanding this point completely or not? I hope you are understanding it very nicely and completely. Okay, so this was our positive clamper circuit. Let's move on to the negative clamper circuit. Before that, we will see a question where we need to draw the output waveform. Why we are taking this question? Because I don't want you to mug up the things, but to understand the things. So try it on your own. This is my input voltage. I hope you can see the input voltage. This is simply a square waveform, and you need to draw the output waveform. And the value of time t is given as 2 RC. That means the RC value is not very large and not very low. Are you getting this point? RC value is not very large. If it was very large, it should have been something like this. The T is very greater than RC, or T is very if it is very low, it would have been like this. But RC value is good enough this time. And also you need to find the time. Also, you need to draw the output waveform, and then you need to find the time in which the output reduces to 4.3 volt, 4.32 volt. Okay, at the time when output is 4.3 volt, reaches to 4.3 volt. So let's analyze the circuit. So this is the circuit given. We can copy it. And we can also copy the input waveform. Let's copy it. Okay, so this is the case. Now my input voltage is 5 volt. This is my input voltage, which is 5 volt. So at the diode, here I am having 5 volt. Here the capacitor is having 0 voltage. So most probably I can think that if it is 0 voltage and if I turn on the diode, what will happen? There will be a current of 5 by R flowing in this direction. Are you getting this point? I don't know if the diode is off or on. I am applying the short circuit test. I am applying the short circuit test. Or you can say you are applying the open circuit test. If you apply the open circuit test, what will happen? Here it is 5 volt and here it will be 0 volt only, right? This input is 5 volt and here there is no charge on this capacitor, so 0 volt, and there is no current in the resistor, so 0 volt. So 5 volt and 0 volt. So the diode will be turned on, right? Diode will be turned on initially when input is 5 volt. So at t equals to 0, what will happen? Diode turns on. And if diode turns on, what will be the circuit? It will be a simple RC circuit. This is RC and this is input voltage. Simple RC circuit is there, input voltage is there. That means this capacitor will get charged now. So how will the capacitor charge? The capacitor will charge like this, 1 minus e to the power minus t by RC. So it has the window of t by 2. It has the window of t by 2, right? So it will charge like this, 1 minus e to the power minus t by 2 RC. So till the time t by 2, it is there, 5 voltage is there. So it will charge like this, and value of t is given is 2 RC. Value of t is given is 2 RC. So it will be 5 into 1 minus e to the power minus 1. So what is the value we are getting? Three point 3.16 volt. So what is happening? Simply your output voltage is charging from 0 to, and it is charged till 3.16 volt because t is given as 2 RC. And we had the window of t by 2, so at time t I took 2 RC, right? So till this time it is charged, and it is charged till this is t by 2, and it is charged till 3.16 0.16 volt. Now at t equals to t by 2 plus, what is happening? At t equals to t by 2 plus, the input is gone. At t equals to t by 2 plus, the input is gone. That means this side is shorted. This side is 0. Now the diode is there. Diode is there in this direction only. And this capacitor is charged to 3.16 volt. 3.16 volt. This is R and this is V naught. Let's apply open circuit test. So what will happen? This voltage 3.16 will go here, and from here 0 voltage is there. So what will happen? The diode turns off. What did we do? In the first cycle, the capacitor was getting charged. Capacitor is charged to 3.16 volt. Now input is gone. Input is 0 now. Input is 0. Input is gone. So this side is at 0 and this side is at plus 3.16. That means diode turns off. Diode turns off. And if the diode turns off, what will be the circuit? This will be the circuit. Diode turns off. So tell me, what will happen to the capacitor? Will the capacitor discharge? No, there is no path to discharge. If it was grounded, it could have discharged. But this is not grounded. This is open circuited. Tell me, if this capacitor is charged to 3 volt, this is my circuit. This is open ended. Now it is charged to 3 volt. What will be the voltage of capacitor at t equals to 10 lakh second? At t equals to 10 lakh second. After 10,000 years, what will be the capacitor voltage? It will always be 3 volt because it is open ended. It cannot discharge. Now if I say this is my circuit, tell me what will be the voltage of capacitor at t equals to 0 plus. Immediately it will discharge because there is no resistor, so it will discharge immediately to 0 volt. But now it is open ended, so it will not discharge. It will remain at 3.16 volt only until diode turns on and something happens. But if the diode is off, at least till that time it will be off only and it will be at 3.16 only. So for 0 to t by 2, not 0 to t by 2, it is t by 2 to t. So for t by 2 to t, diode is off and V naught voltage will be at 3.16 volt, right? So it will always be at 3.16 volt till t by 2. Not t by 2, sorry, till time t. Till time t, it will be at 3.16 volt only. Now what is happening? Again the input is coming back. Here the input was gone, but now again input is coming back. At t equals to t plus, what is happening? The input is coming back. This is the diode. There is this resistor. This is the capacitor. This capacitor is charged to 3.16 volt. This is V naught. This is resistance R and this is 5 volt. Now what we are doing? We will again apply the open circuit test. So this is the 5 volt and this will be 3.16 volt. So what will happen? The diode turns on. Diode turns on. The diode turns on. That means again it will be charging. So what will be your V naught voltage? Initially it is already having 3.16 volt and it wants to go to 5 volt. It wants to go to 5 volt, but initially it is having 3.16 volt. So 5 plus 3.16 minus 5 e to the power minus t minus t by RC. Why t minus t by RC? Because we are starting from time t. Here we were starting from t equals to 0, so I wrote t minus 0 by RC. And here we are starting from time t equals to t, that's why I wrote time t minus t by RC. Because from here t by 2 to 3t by 2, I have the window of t by 2 time only, I have the window of t by 2 time only. From t to 3t by 2, I have the window of t by 2 time only, right? So that's why I need to write t minus t by RC. So again it will be charging, again exponentially it will be charging, like here again it will be exponentially charging. So it will again exponentially charge, but till what value, that we need to see. So till what value it will charge. So let's check the value of V naught at 3t by 2. That will be 5. It will be 5 minus 1.84 e to the power. Here I am putting 3t by 2, so it will be t by 2 RC. Basically it has the window of t by 2 time. Basically that is the mean. T by 2 time it is on, t by 2 time it is off, t by 2 time it is on, t by 2 time it is off. So it has the window of t by 2 time. So and t value is given is 2 RC, that is given. So from there you can find the value of V naught at 3t by 2. V naught at 3t by 2, minus sign is there. So it will be 1 plus minus e to the power 1 into 1.84 minus 5. So it would be 4.32 volt. So at time t equals to 3t by 2, it reaches 4.32 volt. So it reaches 4.32 volt. This is 4.32 volt. After that, what do you think what will happen? Again the input is gone. For the next cycle, this is the last cycle I am drawing. Again the input is gone. For 3t by 2 to t, what is happening? Input is gone. Again this is diode, and this is the capacitor C, which is charged to 4.32 volt. 4.32 volt. What will happen? This is 4.32 and this is 0. That means diode will be off. And if diode is off, that means capacitor remains at 4.32 volt only. V naught remains at 4.32 volt only. So that way the waveform will keep on going. Again constant, then rising, then again constant, then again rising, and at some time it will reach till 5 volt and will remain there. Although it will reach to 5 volt at infinity because it can't charge till 5 volt, but nearly 5 volt only it will reach. So that way the waveform will keep on going. Are you getting this point? So why I took this question? Because you should never take any circuit for granted. Okay, I know the standard circuit of clamper circuit, I know the standard circuit of peak detector circuit. In the later part we will study about peak detector circuit. So this looks like a peak detector circuit and acting as a peak detector circuit only, but not in one cycle, but in many cycles. So that's why I want you to analyze the circuit. Never take any circuit for granted. But if you just see these kind of circuit in the examination, this is the standard circuit only. Directly standard circuit is coming, no change in the input, no change, nothing. Simply the same input and same kind of circuit is given and they are asking the output. Then you can directly write the output. But even if there is a slight change, you should consider solving the circuit rather than writing the output directly. Okay. Now I will tell you a simple trick to how to determine the clamper circuit. Because if we study a lot of circuit, we will be confused whether it is clamper or clipper or it will be positive clamper or negative clamper or it is a peak detector. So in clamper circuit, the output and diode will always be in parallel. In clamper, output and diode will always be in parallel. Okay, this is one thing. And other thing, how you will determine it is positive clamper or negative clamper. So in positive clamper, the diode is like this, arrow is like this, right? The arrow of diode shift looking upward. That means this is a positive clamper. Arrow of diode is like this, that it is positive clamper. If the diode is made like this, that means arrow is downward, that means it will be negative clamper. If the arrow is downward like this, that means that will be negative clamper. If the arrow is upward, that is the positive clamper. That's how you can remember. And when we study peak detector circuit, we will see that peak detector circuit will be somewhat like this. In peak detector, the output is connected to the capacitor. The output is parallel to the capacitor. So in pre-detector circuit, you can also directly see the circuit, right? So this is just a way to remember that if arrow is upward, that means it is positive clamper. Arrow is downward, that means it will shift the waveform downward. Just a way to remember. Or you can analyze the circuit as well, but we will not waste much of time in the examination if the standard circuit comes. If there is standard circuit, we will quickly solve the problem. But if there are no standard circuit, we should have the aptitude, we should have the knowledge to solve the circuit like this. At least these kind of circuits we will be solving, right? So if you have studied network analysis from me, there also I have dealt these kind of questions. So you will be very comfortable with the capacitor, I hope. Let's study the negative clamper circuit. Now it will be a cakewalk for you. First, try to analyze the circuit on your own, then only see my solution. You can do it. You can certainly analyze the circuit on your own. First, try to do it, then you can see my solution. So let's start. Initially, what is happening? The input voltage is rising. What will happen? For 0 to t by 2. Let's take the time window for 0 to t by 2. Input is positive. What will happen? The same, initially the capacitor is 0. VC voltage is 0. Initially, VC voltage at t equals to 0 plus is 0 volt only. So what will happen? The complete voltage will be going across the diode. The input voltage, positive voltage is going across the diode. Let's assume this is some 0.1 volt. So at that time only the diode will turn on. At that time only the diode will turn on. In positive clamper, this thing was happening at t by 2. The same thing, the diode turning on, that was happening at t by 2 plus. But in the negative clamper, it is happening at t equals to 0 only. So at t equals to 0 plus, I should write at t equals to 0 plus, the diode turns on. Diode turns on. Now if the diode turns on, how will our circuit look like? This is capacitor C, this is VC, the diode turns on. I don't need to make R because R parallel 0 will be 0 only. And this is my V naught. Now my diode turns on. So basically what is happening? My capacitor voltage is following my input. So now what is my input? Input is like this. So the capacitor will charge in the positive direction, right? Better I should make the input till this time only. So now what is happening? The capacitor is getting charged in this direction. So for 0 to t by 2, V naught will be at 0 volt only and Vc will be charging. Vc will be equal to Vin only. Why did I take 0 to why did I take till t by 2 only? Why so? Why did not I not t by 2? It should be t by 4. Sorry for that. It should be t by 4. Should be t by 4. Really sorry for that. Why did I took for t by 4 only? Why did not I took till t by 2? Because at t by 4, let's talk at t by 4. What is happening? The capacitor is following the input voltage. So if we are assuming Vin to be 5 volt, so till t by 4 it would have been charged to 5 volt. At t by 4 plus, what is happening? The input voltage is going to 4.9. Now this is 4.9 and this is charged to 5 volt in this direction because the capacitor cannot change its voltage immediately. So this will be at 5 volt only, but the input is going for 4.9. If this is 4.9 and this is 5, so 4.9 minus 5, this will be minus 0.1. What will happen? The diode turns off. Are you getting this point? Why I was not worried about this thing for 0 to t by 2 in this region? Why I was not worried about this thing? Let's check that. Why I was not worried about this thing in this particular region? Why? Let's take this point. Let's assume at this point my input voltage is 2 volt. At this point my input voltage is 2 volt. So what is happening? My input voltage is 2 volt. That means my capacitor will also be charged to 2 volt only. The same voltage. Because it is following the input. At the next moment what will happen? My input voltage will go to 2.1 volt. At the next moment my input voltage will go to 2.1 volt. So 2.1 volt, this is 2.1 volt and this is charged to 2 volt. What will be the voltage here? 2.1 minus 2, it will be 0.1. the next voltage is greater than the capacitor voltage. If the next voltage is greater than the capacitor voltage, if my next input voltage is greater than the capacitor voltage, that means at the diode I am going to have positive voltage only. And if there is positive voltage only, that means the diode will not change its condition, it will remain turned on only. And if it is remaining turned on only, that means it will be following my input. The capacitor voltage will be following my input. So I don't need to worry. But at T by 4, I know one thing, that till T by 4 it is following my input. But at the next point, my input is changing its voltage. From 5 to it is going to 4.9. And the capacitor is charged to 5 volt only. So 4.9 minus 5 will be minus 1. And at that time my diode will be turned off. So that's the issue. That's why I analyze till 0 to T by 4. So whenever my input voltage is changing its voltage, whenever changing not its voltage, whenever the input voltage is changing its, what do we say, changing its nature, the input voltage initially was rising, now it is falling, then again rise, again fall. So whenever the input voltage is changing its nature, increasing or decreasing, so after T by 4 it is decreasing. So at T by 4 plus I need to check what is happening. So that's the reason I checked at T by 4 plus. In the previous analysis, if you see, where did we check? We did not check at this point. Why so? Because the diode was not even turned on, the diode was off only. But when it turned on, we checked at 3T by 4 plus. When the diode turned on, we checked at this point and we found something suspicious. What was that? The diode was turning off. If the diode was turning off, it was always remaining turned off only. Are you getting this point or not? So that's why here as well we will check at T by 4 plus. Like many times I have seen students solving the problem of a clamper circuit, but they don't even know why we are checking this point. Right? They don't even know why we are checking this point. The reason of checking this point is that graph is changing its nature. First it was increasing only, but now it is decreasing. So that's why we need to check. So at T by 4 plus, what is happening? The input voltage is getting less. Let's assume 4.9 volt. So what will happen? My diode will be turned off. And if my diode is turned off, then you know what happens. So we will see that, but till now we will write down whatever that we have covered. For now we are going to write down what we have covered, and that is, so for 0 to T by 4 we have written V0 is 0 volt and Vc is equals to V in only. So Vc is equals to V in only. Now it is charged till this point. So Vc is equals to V in only and our V0 is 0 volt. V0 is 0 volt. Now at T equals to T by 4 plus, what is happening? This is my capacitor and this is my diode. This is V0, this is capacitor, this is input voltage, this is charged to 5 volt in this direction, right? Or Vm you can say. This is charged to 5 volt or Vm you can say. After, in the next moment, what is happening? Here it is becoming 4.9 volt. So what will be the voltage here? 4.9 minus 5, it will be minus 0.1 volt. What is happening? The diode turns off. The diode turns off. Now to turn on the diode, what do you need to do? The diode turns on, but if the diode turns on, the capacitor can never charge or discharge. Can neither charge nor discharge. Why so? Because RC value is very large. Nor discharge. RC is very large. Now you need to turn on the diode, but how will you turn on the diode? For turning on the diode, what do you need to do? Input voltage minus 5 volt should be greater than 0. This is my input. this was my input. Input minus 5, because capacitor can neither charge nor discharge. Capacitor can neither charge nor discharge. So capacitor will be at 5 volt only. So V in minus 5, that is VD. This is our VD. This is our VD. So V in minus 5 should be greater than 0. That means V in should be greater than 5, and which is not possible. This is not possible. And if this is not possible, then what will happen? It is not possible. So the diode can never turn on. Diode can never turn on. So what does that mean? That means that Vc will always be at 5 volt, always, and V0 will be V in minus 5 volt. Why minus 5 volt? Because this is V in and this is plus 5. So V in minus 5, that will be our V0. Simple KVL it is, V in minus 5 is equals to V0. So this is our fixed voltage. This is happening when? After that, after T by 4 plus. So for T by 4 plus, Vc is always at 5 volt only. It is always at plus Vm only. And input is V in minus Vm. So at Vm you are having 0. At this point, you will be having some negative voltage. This is somewhat less. Let's assume if it is 5, this will be 4.9. So at this point, your voltage would be V in minus Vm. That means 4.9 minus 5, some negative voltage, right? Some negative voltage. Some negative voltage. Then at T by 2, what will happen? V in minus 5, that means 0 minus 5. At T by 2 plus, input voltage, at T by 2, input voltage is 0. So 0 minus 5, that means minus 5. At T by 2, it will be minus 5. At 3T by 4, it will be minus 5, minus 5. V in minus 5. What is our output? Output is V in minus 5. So at 3T by 4, you are having minus 5 input voltage. So minus 5 will be minus 10. So like that, it is decreasing. So let's first make the points, then it will be easier. And at plus 5, it will again go to 0. I guess it will be a tough task to make the waveform. So let's try making the waveform. Okay. So at 3T by 4, I need to make minus 10. So like that it will be going. I hope you have understood the point. You are not much interested in the waveform, but you are interested in the concept, right? At 3T by 4, you are having minus 2 Vm. This is minus 2 Vm. And this is minus Vm. This is also minus Vm. I hope you have understood the concept. The output voltage is shifted downward, right? Output voltage is simply shifted downward. Well and good. So you have understood positive clamper and negative clamper. Let's quickly revise negative clamper, which was a very simple circuit. Firstly, the diode turns on. That means the input is following the diode. The capacitor voltage is following the input. So the capacitor gets charged to 5 volt. After that, what will happen? The capacitor is at 5 volt only, but the input is getting decreased. If the input is decreased, that means diode turns off. And if the diode turns off, it will never again turn on. In the complete clamper circuit, whenever you see, if first time the diode turns off, that means it will never get turned on. But we will take some examples where the diode turns on later on as well. So that also we will take, but let's wait for it. So yeah, the diode can never turn on. So what will happen? The output voltage, the capacitor voltage will be fixed at 5 volt only, and the output voltage will be V in minus 5 volt. And how to remember this is negative clamper? Because it is arrow is downward. If you see the diode, arrow is downward. So that's how you can remember it is negative clamper. That means it will shift the input voltage downward. So it is shifting the input voltage to downward. Okay. So yeah, the input voltage is being shifted downwards. Right. Now we will see a simpler method to solve the clamper circuit in one step only. How to solve the clamper circuit in one step, but that we will see in the next video. In the next video we will see this method, and also we will solve many examples. After that we will see voltage multiplier, voltage multipliers, voltage doubler, tripler, and then we will see peak detector circuit, and with that we will be closing our chapter. Okay, thank you.